So this assignment is related to alcohols and halogen alkenes, the topic we completed the last session. The table gives some data on fuel. Which fuel produces the smallest mass of carbon dioxide on combustion to generate 100 megajoule of energy? As you can see, these energy densities are given, like it produced 33 megajoule when and produced 2.5 kilogram per liter of carbon dioxide. So the question is, which one produce the smallest amount of carbon dioxide for 100 megajoule? What could be the right answer for this? Question 1. The correct answer is B, the LPG, because you have to work out the ratio. Like for biodiesel, when you find for biodiesel, if you have 33 megajoule of biodiesel, when it produces 33 megajoule, how much carbon dioxide gas is released? The mass of the carbon dioxide, that is 2.5. But we need for 100, so 100 will be X. And same thing you will repeat if 24 is producing 1.5, 24 megajoule of energy when it is there for per liter, it is 1.5. So if 100 is there, that will be X. Cross multiply, you will find the answers, and the smallest answer for carbon dioxide will be LPG. That's why B is the right answer. Which combustion of ethanol produce no change in volume of a gas present at room temperature? Means the moles of a gas will not change, the volume of the gas. The moles of a gas of reactant, volume of a gas of, or moles of the reactant gases equal to moles of product gas. What's the right answer for question 2? So C is the right answer, because here you have 3 moles, 2 moles of a gas, 1 mole of a gas, and there is no mole of a gas. 2 moles of a gas in reactant and 2 moles of a gas in product. So moles of gas are same, they will occupy the same volume. So there will be no change in the volume for a gas present at room temperature. Then grass is similar to many other plants, naturally releasing a mixture of volatile organic compound. Freshly cut grass has a characteristic aroma because of increased release of these compounds, and which are known as the green leaf, volatiles. The most important contributor to this aroma are alcohols and aldehyde containing 6 carbon atoms. The main compound giving a freshly cut grass its smell is Z-hex-3-enol. The human nose can detect Z-hex-3-enol at a level low as 1 nanogram per decimeter cube. However, this compound is relatively unstable and rearranged to form E isomer. So this one is, first it is Z, then it will become E isomer. Some other GLBs are methanol, ethanol, Z-hex-3-enol, and hex2-enol. It has been suggested that the release of these GLBs is a part of defense response by the plants. In one study, the plant attacked by a caterpillar, the chemical composition of GLB changes to attract the natural insect, the predator of these caterpillars. Give a molecular formula of Z-hex-3-enol. So this is Z-hex-3-enol. What is the molecular formula? The term molecular formula means the actual number of atoms. So how many carbon atoms, how many hydrogen, and how many oxygen atoms are there? that should have a 6 carbon atoms. So the first one to have a 6 carbon atoms, it will be CH3. Structural formula in which you show the minimal detail: CH3, CH3, CH2, CH2, CH2OH. And name of this compound, that will be hexane all. And then we have to draw the secondary. The secondary alcohol. So how to draw a secondary alcohol? Just change the position. The OH can be attached with the second carbon or the third carbon. So it will be CH3, CH2, 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 1, 2, 3, 4, CH. Then OH is attached with this one, and then CH3. And what is the name of this compound? This is hexane 2-ol. The compound 2-chloro 2-methyl pentane has 6 carbon atoms. It can be converted into tertiary alcohol by aqueous sodium hydroxide. Complete the equation. So we have to complete the equation. We want to convert this into alcohol. So what happened? The OH group, which is a nucleophile, will attack on this. So you can write the reagent sodium hydroxide, and OH group will replace this Cl. So what it result? It result in CH3, CH3, OH will be there, CH2, CH2, CH3, and then Cl group will react with sodium and it will produce sodium chloride, NaCl. What class of reagent is hydroxide in this reaction? So what we call, because this hydroxide attack on the partial positive, so we call that as nucleophile, attracted towards the electron deficient side or the positive center. In different conditions, 2-chloro 2-methyl undergo an elimination reaction. Elimination reaction of halogen alkane forms alkene. Complete the equation, complete the reaction mechanism, appropriate curly arrow, essential condition for this reaction. So basically what happened, this hydroxide ion will attract this hydrogen and carbon will form a double bond, and the chlorine will also leave by taking both electrons. So the resultant molecule will be an alkene. CH3 is there, CH3. Between these two carbon, because halogen will leave and hydrogen will leave, so they will have a double bond. Hydrogen is there, then CH2 and CH3. And H and OH is being removed. So when H and OH removed, so it will produce water, H2O, and the chloride ion is there, which is also taking both of the electrons, so Cl will be there. Then what are the reaction conditions for this? We need alcoholic medium or aqueous. It should not be aqueous, it should be alkali in alcoholic medium, result in the formation of this product. the alcohol will be there as a solvent. Methanol and ethanol are both GLVs, and there are number of fragment peaks which appear in a mass spectra of both compounds. But somewhat surprisingly, OH peaks mass to charge is not one of them. Suggest the formula for M by E values of the two fragments that we expect to occur in both spectrum of methanol and ethanol. So if I draw the structure of these methanol and ethanol, what is the structure of methanol? So methanol means CH3OH, and ethanol means CH3CH2OH. So we have to name the fragment which is somewhat surprisingly, the OH peaks at M2E17 is not one of them. So which one is there? When we break down into its fragment in a mass spectrometer, it will break down into multiple fragments. So when we write the possible fragments for this, so this might break into CH3 and OH. This is one of the fragment in a mass spectrometer. Or if it dissociate or break down in this spectrum CH3 and OH, so where we will get a peak of CH3, carbon is 12 and hydrogen is 1, so multiply by 3, so we'll get a peak at 13, sorry 15. And same way, when methanol, when this another possible fragment or dissociation of this, when we dissociate this ethanol, so the fragment it might break into CH3. The mass spectrum and infrared spectroscopy of unit 2 is also there. Unit 2 is about the molecule, how when we use a mass spectrum the molecule dissociated to possible fragments. In case of ethanol, CH3 will be there, CH2 and OH will be a radical. This is one possibility. Or it might be CH3 one radical and CH2 and OH will be the fragment which we detect. So if we detect this fragment, we can detect at 15. If we detect CH2 and OH, so carbon is 12 plus hydrogen 16, 12 plus 16, 28, and plus 2, 30 plus 1, 31. So we'll detect a peak at 31. So the possible fragments which we can have, it can be 15 or it can be 31. Because we have to tell which will occur in both. So 15 can be there. This can also, the total cannot be 31, but when you find the whole molecule, because carbon is 12 plus oxygen 16, 12 plus 16, 28 plus, if one of the hydrogen is lost from this, so it will be CH3 and O. So that fragment will also be 31. So the first fragment can be CH3, which can be there in both, and the second fragment can be at 31. Then give a formula of one fragment of ion that could be expected to present in both ethanol but absent in methanol. So what we can find in ethanol but we cannot find in methanol. So that is C2H5, because in methanol we have CH3OH. So maybe it will dissociate into CH3 and OH. But if we have ethanol, ethanol is C2H5OH. So it will dissociate into C2H5 and OH. So C2H5 we can find in ethanol, but we cannot find in methanol. Z hex 3-ene-1-ol is sparingly soluble, slightly soluble in water, but it is completely miscible in ethanol. By reference to intermolecular forces, explain the difference in solubility. Means why it is slightly soluble in water, but it is completely miscible or soluble in ethanol. So what could be a reason when we draw the structure? So it contains a carbon-carbon double bond. It is first position, OH group is there, and there's a carbon chain. So what kind of intermolecular forces are there in hex 3-ene-1-ol? It will have dipole-dipole force, it will have hydrogen bond, and it will have dipole-induced dipole forces as well. Because there is CO bond will be there, that's why all the type of forces. But in water, only hydrogen bonds are there. So it can form hydrogen bond with water, that's why it is sparingly soluble. But in case of methanol, ethanol means carbon atoms are there. So there is a dipole, induced dipole force. There is CO bond, so means dipole force is there. And there is OH, the oxygen bonded with hydrogen. So hydrogen bond is also there. So they have identical type of forces. So when two molecules have identical type of forces, they are miscible. That's why this is completely miscible with ethanol, but it is slightly or sparingly soluble in water. So when you mention your answer, write your answer, you will mention first that there are the forces which are present, intermolecular forces which are present is London forces, dipole-dipole forces, or hydrogen bonds are there. But and in hex, the second one, mostly because the carbon chain is there, so it's non-polar, and dipole-induced dipole force are present in ethanol as well. So identical forces, that's why the two molecules are completely miscible. At least you should mention about two of the forces present in the or common forces between hex 3-ene-1-ol and ethanol. Which is tertiary halogen alkane? Which one of them is tertiary halogen alkane? Tertiary halogen refers to a carbon which is bonded with halogen surrounded by three alkyl groups. What could be the right answer for question 4? Yes, C is the right answer, because when you draw the structure of C, the carbon bonded with bromine and it is surrounded by three alkyl groups. So that's why this carbon is refers to tertiary carbon. The structure in terms of common name, it's a tertiary compound. Propene can be formed by heating 1-bromopropane with alcoholic potassium hydroxide. This reaction, you have alcoholic potassium hydroxide, means in alcoholic medium, halogen alkane undergo a reaction to form alkene. What we call this reaction? Question 5. Yes, there is elimination reaction when halogen alkane reacted with potassium hydroxide in alcoholic medium. Question 6. The compound with empirical formula C3H6O could be empirical formula. So means you have to just work out the structure, write the molecular formula and check which one is the empirical formula by taking a simplest ratio between the atoms present in the structure. So when we write hexanoic acid and when we draw the structure of hexanoic acid, so it is C5H11COH. So total there are 6 carbon atoms, hydrogen, 12 hydrogen atoms are there and 2 oxygen. When we take a simplest ratio between the atoms present in the structure, so C3, H6 and O. So that matches with hexanoic acid. When you draw the structure of hexane 1,2 diol or hexane 2 ol or hexane 2 on, the ketone, you will find that it is different. Equal amount of 1-chlorobutane and 1-iodobutane are formed with aqueous silver nitrate in the presence of ethanol. Why does 1-chlorobutane react more slowly? What could be the reason for that? Why it does not react quickly or react slowly? What could be the reason? Question 7. Because the bond, basically it is related to the bond. If bond strength is more, bond energy is higher, it will take more energy to break down the bond, so reaction will be slower. So we'll do MCQs right now, multiple choice questions. Which of these compounds would not react when heated with a mixture of potassium dichromate and sulfuric acid? Basically, potassium dichromate is an oxidizing agent. Acidified potassium dichromate is an oxidizing agent. Which alcohol cannot be oxidized? Primary alcohol can be oxidized to carboxylic acid, first aldehyde and then to carboxylic. Secondary alcohol can be oxidized to ketone, and tertiary alcohol cannot be oxidized. So which one of them is a tertiary alcohol? When you draw the structure of this one, so CH3, CH2, CH2OH. So when you draw this structure, according to this structure, this one is primary, this one is also a primary, this one is secondary, and the last one is tertiary. So D is a tertiary alcohol, cannot be oxidized by acidified potassium dichromate 6. Which of the following is a secondary alcohol? Which of the following is a secondary alcohol? So when you draw the structure, 2-methyl pentane 3-ol. So pent means 5 carbon. So first we have to draw the 5 carbon atoms, 1, 2, 3, 4, 5. Second position we have a methyl group, and third position we have OH. So when you draw the structure, this one is CH3, CH, CH, CH2, CH3. So you can see the carbon which is bonded with OH, there are two carbon chains next to this. So means this one is a secondary alcohol. If I draw the third one, this B part B, 2-methyl propane 2-ol. So prop means 3 carbon, OH is there, and CH3, CH3, and CH3. So OH group is attached with the carbon and it is surrounded by 3 carbon chains. So this is not the secondary, this is the tertiary. So A is the right answer. The reaction of halogen alkane with alcoholic ammonia is what kind of reaction of alcoholic ammonia with halogen alkane? It's a nucleophilic with ammonia, also nucleophilic substitution. With potassium hydroxide, if it is an aqueous, nucleophilic substitution. If it is alcoholic, then elimination reaction. Formation of carbon cation from halogen alkane is example of when carbon cation is formed from halogen alkane. What is it, this example? Type of bond breaking, homolytic or heterolytic? Because it's a charges are formed, so that's why it is heterolytic fission or heterolytic bond breaking. In question 16, which of the following is a secondary alcohol? So when you draw butane 2-ol, but means 4 carbon, and OH group is there. Butane 1-ol, it's a primary alcohol, but when you draw butane 2-ol, so but means 4 carbon atoms and OH group is attached with the second one, so this is one carbon chain, the second carbon chain, that's why it is secondary alcohol. The compound skeletal formula is given. What is the systematic name of this compound? Question 17, the systematic name of this compound. When we number the carbon atom, numbering should start from nearest branch or a double bond. A functional group. Second position we have a chlorine. So it's 2-chloro because there are 4 carbon atom but and single bond in. So it is 2-chloro-butane. Question 18. When chloroalkane is heated with aqueous sodium hydroxide, what will happen? No reaction occur. Reaction occur with primary and secondary but not with tertiary. Reaction occur with tertiary but not with primary secondary, or reaction occur with primary secondary and tertiary all. So halogen alkane, primary secondary and tertiary all will react. That's why D is the right answer. Alcohols, tertiary alcohols cannot be oxidized. So these are the questions related to some questions related to alcohols and halogen alkane. Next week I'll start a new topic which is about the energetics, the chemical energetics. Any question related to the class? I already shared this assignment with you, so you can go through the assignment and solve questions from the assignment.